Macmillan Audio presents The Copernicus Complex, Our Cosmic Significance in a Universe of Planets and Probabilities, by Caleb Scharf. Read for you by the author.
Prologue. From Microcosm to Cosmos. It all begins with a single drop of water. With one eye scrunched shut, the drapery tradesman and budding scientist Antony van Leeuwenhoek stares intently through the tiny lens he has fashioned from a piece of soda-lime glass. On the other side of this shiny bead is a quivering sample of lake water, scooped up during an outing the previous day around the city of Delft in the Netherlands. As he adjusts the instrument and lets his eye relax and focus, van Leeuwenhoek suddenly finds himself falling headlong into a new world, a swarming metropolis of alien design. Within the previously invisible universe of this single speck of water are arrays of beautifully coiled spirals, animated blobs, and bell-shaped creatures with skinny tails, wiggling, gyrating, and swimming busily with absolutely no regard for his right to be peering in at them. It's a shocking vision. Van Leeuwenhoek is not just a human, he is a cosmically huge giant, observing another world contained within his own. And if this one drop can be home to its own universe, then what about another, and all the drops of water on Earth? The year is 1674. A time sandwiched between some of the most profound changes in Western science and thought. A little more than a century earlier, Polish scientist and polymath Nicolaus Copernicus had published De Revolutionibus Orbium Celestium, on the revolutions of the celestial spheres. In this book, Copernicus had put forth his completed heliocentric model of the universe, shifting the Earth from the center of the cosmos to a secondary place, spinning and orbiting around the sun, a demotion that would reshape our species' scientific history. In the intervening decades, the Italian Galileo Galilei had built his telescopes and seen the moons of Jupiter and phases of Venus, convincing him that Copernicus was right. A heretical view at the time, one that cost him dearly when it attracted the scrutiny of the Roman Inquisition. His contemporary, the German Johannes Kepler, went even further by stating that the orbits of the planets, including the Earth, traced not perfect circles, but rather eccentric ellipses, unsettling any conception of a rational universe. And in a little over 10 years' time, from when we find van Leeuwenhoek gazing through his lens, the great English scientist Isaac Newton will publish his monumental Principia, laying out the laws of gravitation and mechanics that will, unwittingly, make the arrangement of our solar system and of the universe at large a thing of austere beauty, untended by any guiding hand but physics and mathematics. It is, by any standards, an extraordinary time in human history. Antony van Leeuwenhoek was born into this rapidly transforming world in 1632 in Delft. His early life was relatively ordinary. He never received much education beyond the basics. As a young man, he quickly established himself as a tradesman, dealing successfully in linens and woolens. He was also a relentlessly interested and curious person, once describing himself as craving after knowledge, a characteristic that would result in a voluminous legacy of observations and writings about his greatest passion, the microcosm. Sometime in the year 1665, van Leeuwenhoek came across the great work Micrographia by the English scientist Robert Hooke. Micrographia was a phenomenon, the first major publication of the fledgling Royal Society in England, the first best-selling science book, and a cornucopia of the most fabulously detailed illustrations of the magnified textures of everything, from insects to minerals, bird feathers, and plant life. It was an atlas of the world.
Sample complete. Ready to continue?